Hi everyone, I'm Amanda O'Brien and this is Lindsay Bungert, and today we'll be presenting our work on developing a self-report measure of prediction. And we developed this measure in collaboration with the individuals listed here. Today we'll go over our rationale for developing this survey, talk about the development process, describe some preliminary results from our field testing, and discuss our next steps. In 2014, there were a series of papers that suggested that differences in prediction skills in autistic individuals may explain some of the challenges that are associated with autism. We conducted a systematic review of the empirical evidence for this hypothesis in 2021, and you can link to our review here. One thing that we noticed was that there is not currently a self-report measure of prediction, and that's what we aim to do with this survey. So our goals were to create a normally distributed self-report measure that would allow us to quantify somebody's prediction skills. Our first goal was to identify and distinguish between individuals who are strong predictors and those who are weak predictors. And this includes, but is not limited to, autistic individuals. We ultimately hope to be able to compare the results from this survey to performance of individuals on more abstract lab-based prediction tasks. First, we needed to define what prediction is. So we created this model of prediction that involves this loop. So initially, for a prediction, you need to have a mental model, which is this understanding of causality. One example could be that lightning occurs and then thunder happens after. Based on that mental model, you can make an inference. You use your mental model to generate a prediction. You see lightning, you expect thunder. You can then deploy the prediction. So this is a behavioral response or a neural response. It could be a difference in eye gaze that is used in preparation or in expectation of what is about to occur based on your inference. So maybe you cover your ears in anticipation of the thunder. And then you might have surprise. So this is a neuromodulatory or emotional response based on your deployment of prediction, based on what actually occurred. And you could use this surprise to update your model. So maybe the thunder was louder than you expected, or maybe the thunder occurred closer to the lightning. And you can use that in your future use of your mental model. And the loop begins again. So the definition is also written out here, and I'll leave that for you to read on your own time. So after defining prediction, we then wanted to create a list of behaviors that would represent this construct that we could use in our survey. We then had our experts rate the items in terms of how much they represented a prediction, and then sort the items into their phases as described by this loop, because we wanted to make sure that the items were actually capturing our definition of prediction. Based on that, we were able to develop an instrument that was our initial pilot survey, and then we used some piloting in order to revise the wording. We then field tested the revised instrument in a population of individuals with and without autism. And we've validated the revised instrument using Rationale modeling, which Lindsay will describe shortly. Based on the results from that modeling, we were able to generate some new items to fit some holes that we found from our modeling, and we'll describe that as well. This is where we currently are. We're about to field test our revised instrument. We'll then go through this validation process again, because this is an iterative process. And ultimately, we will end up with a validated and revised instrument.
So here you see an example of some of our sample items, as well as our rating scale. So we have a 4-point Likert scale where participants respond from not at all like me to just like me. And we also included options for I do not understand the question or I have not been in this situation to allow participants to give us feedback about items that just aren't working for them. We had 109 participants, 55 neurotypical or non-autistic adults, and 54 autistic adults, and they were matched for age range, gender distribution, nonverbal IQ, and measures of verbal capacity. So we wanted to look to see if both of our samples were normally distributed. And using statistical testing, we found that they were in fact both normally distributed, although their means were different. So over here on the left, you'll see our neurotypical or non-autistic mean was 116.3 versus our autistic mean of 88.5. And those two are statistically significant in their difference with a p-value of less than 0.0001. So here, this figure is a little bit messy, but these are some of our results from our Roche modeling. And so you'll see on the right the distribution of our items. And those items that are over there on the bottom, those are items that are very easy for participants to respond to. You can see that our participants over on the left, which is a distribution of those hashtags represent 2 participants and the period represents 1 participant, with our means in the middle. So we've got the mean on the left, our participant mean, the mean lower on the right is our item mean. So what this tells us is that big gap between those two means is that our participants are capable of answering a lot more challenging items than we've been giving them. The mean for the items is pretty low, telling us most of our items are pretty easy and our participants are answering them. And we're not really capturing the full range of skills for our participants. So you can see up on the top, there's a little bit of a gap there where we don't have any items. And that's where we'd like to start filling in some gaps and adding some more challenging items to better capture the skills of our participants. So we've gone ahead and used some open-ended questions to get some responses from our current participants with looking at specifically the responses from our autistic participants that have given us a lot of great insight into what's most challenging for them to help us generate some more difficult items. And we'll be testing and validating those as we move forward. If you're interested in contributing and giving us some feedback on these questions, you can go ahead and scan the QR code and you'll be directed to that little survey. We want to thank you for your time today, and as well as a huge thank you to our development team that has helped us this past year. We wouldn't have been able to do any of this work without them. Thank you all for your time.